So I think we can just get going here. Yeah, I think it's 10. So in paying respect to punctuality, I guess I'll get going here. So like we've been mentioning, I'd like to have, I'd like to invite everyone here for the Launchable community for the Q&A and follow-up discussions and so on. So follow the link and join us in the Discord. Okay, so in the world of continuous security, right? I think we are all chasing after the speed, and that's the name of the game. Now we can go very fast if you don't need to, if you don't care about the crashing, burning. So really, the challenge to go fast is to how to maintain the quality and the speed, right? I think that's the challenge I see everywhere. Now, I think the key, for me, the kind of key way is to go faster, because if you're just repeating the same process 10 times faster, it's going to burn. It's going to cause enough friction and burn up. So the key to go faster is to, to think of this like the film strip, right? If you have like a 24 frames per second, and if you compare 2 frames next to each other, the delta is going to be really small. So when you're increasing the frequency of deployment or testing or code changes, what's going to also happen is that the amount of change that happens in between those 2 snapshots is going to get smaller and smaller. So it stands to reason that then it makes more sense to focus on these delta increments. So like I recently came across the word delta testing, and then so that's kind of what I'm trying to what I'm interested in here, and what I'm trying to raise awareness. Is how you can focus on like a small amount of changes and then get the confidence built around that quickly. I think another way to look at what we are doing is, think about the concentrating. So, when I work on Jenkins project, I had 1 hour worth of testing that needs to run for every single PR. And, that's seemingly, that felt really wasteful, right? And then even if you pass all the tests, like, it's not like I had good confidence. So it was like the drinking down the very thin orange juice. So think about what Launchable is trying to do as create a much more concentrated vitamin C. So in any given amount of testing, we can pack a lot more impact. So a couple of ways to use this. One obvious way to use it is in pre-merge, right? So actually, I think this is I'm starting from the other one. So the primary use case is like, if many of you have this nightly test that's taking like multiple hours to run and only running every once a night, well, I think you'd benefit from creating this highly concentrated orange juice. And then instead of 5 hours, you can have 30 minutes testing. Then you can fit that to run throughout the day, which means that you get the feedback a lot more quickly. Right. Another thing, I guess, was another thing that would be to run it on the pull requests. So, I mentioned in Jenkins, just even one line change takes 1 hour to get in. So, like, is that really worthwhile for you to wait and the code reviewers to wait that long? So that's with that the setup. What I'm trying to show you is, imagine I have this like the calculator app, which consists of 4 pieces of components. Each comes with 4 tests, right? And then my challenge is that this PR validation is too slow because let's say 4 test cases are too long, which is obviously a toy setup. But you can imagine, like in your project, you might have instead of 4 components, you might have 400. And instead of 4 tests, you might have 40,000 tests. So I'm sure you can kind of feel the pain. So what I'm going to show here is I'm going to, by using the Launchable, I'll demonstrate that we can pick the one test that best cover the change. So in this case, because it's a trivial setup, we can almost always expect the model to get the right answer. So, actually, let me show you the project first. So, this is a very standard Gradle project. There's nothing unusual about the build setup, and then 4 components of the calculator, implementing the key logic. Really no surprise there, hopefully. And then the 4 test cases that have this corresponding logic there. So, we have the CI process that's already, for the purpose of this demo, which already has the Launchable pre-integrated. So much of the way we've designed this so that it's super easy to get the Launchable installed. So here is the our documentations, and you can see it for yourself. And then there's a dedicated getting started guide, which kind of walks you through the steps of how to get this going. So really, quickly speaking, it just really consists of 3 pieces. The one is this thing is the Python self-contained Python app, so you can just install it. And then there are really 3 pieces here. The one is to tell the let Launchable know where the source code is. So I'm telling the Launchable that, hey, I'm about to commit this test, this commit from this source code repository, and then provide the name for the build. So I'm going to run this on the GitHub action. So this basically just expands the GitHub run ID. This is just like a default value in case I run this outside GitHub actions, which is not too important here. So by telling Launchable where the build happens, like Launchable gets to see the a shape of the commit graph where the source code has changed. And next, I use the Gradle support to ask, okay, this is the test that I'm about to run, and then give me the 25% subset of this test. So in this case, the idea behind 25% is I wanted to pick 1 test out of 4, but you can have arbitrary small target, or you can also set the target by time. So like instead of aiming for the percentage, if you're aiming for 15 minutes worth of testing, you can do that as well. So this is going to return us the test that the Launchable thinks is the best to run, and then what we're going to do is just basically pass that into the Gradle and then have it execute the tests. And then there's a little bit of since I'm writing the whole thing in shell script, at the last step, I'm going to record the test results that the Gradle has produced, so that the Launchable knows which test has passed and which test has failed. And in that way, there are a machine learning platform behind the scene can train any model to make it better. So, all right. So that's the setup. In the real project setup, this is all done by your release engineer or the build guy. So what I'm going to do is I'm going to just, I guess I could use ID. So I'm just going to start editing, making a change. So I'm going to make the, let's say, I don't know, performance optimizations in this, let's say, div algorithm, right? So I know what, I'm just going to do this from the terminal, to go away. So I just made change to the one source file, and I'm making performance improvement to the division algorithm. Right, and then I'm doing things that doing the usual development. So I'm pushing this as like div improvement or something. So creating a new branch. So and then I'm going to create a pull request for this change. I think this default should be fine. Right, so again, the same development flow, really nothing changes. And then now, this CI script is going to start happening. And then, so if you're looking at the output, and let me make this a little bigger. So, what we expected. So normally, right, if this is a large project, you'd have to wait for quite a bit of time before the change would be ready. And then in most places, the code review would happen after the tests are verified to pass. So that's going to be another waiting. And then if that results in any change, then it's going to you have to make a follow-up change and another cycle of testing. All of that adds up to quite a bit of time. Or in some cases, like if you're like me, like when you feel like you're locally ready, right? And then what you want to do is run the test cases so that it finds some errors, and then that drives your next leg of the development. So what can how can you get the quick sanity check on the changes? So those are the situations those are the situations where this kind of rapid testing feedback is really useful. So unfortunately, the GitHub Actions message is kind of verbose. So what we are doing here while we are talking is, you see it's running the command that we were looking at in the shell script, right? So it specified the build, and then it asked what the subset is, and then what the Launchable returned was the div test, so which is kind of what we expect, right? Because we changed the div, the component. If the algorithm is a model, is a machine learning model, is smart, then this is the test that we expected to pick, and then it did. So in this case, I had a regression, so naturally the test caught the problem, and then I was able to inspect the test result, and I would go, okay, so clearly I made the mistake in my optimization, so kind of take it from there. All right, so let's go back and then make a different kind of change. So maybe next time I'm going to change something like the test case. So so maybe you're working on a test case. Right, so changing, let's see, changing the test case, fixing this, I don't know, right? Fixing the assertion. And then let me push this to create another PR, right? The same flow. And then yeah, I think that's good. So again, if I create a pull request, the same thing is going to happen, and it gets tested, and then it's going to be, hopefully, if you do that, well, I shouldn't say hopefully. I have a full confidence that it does pick the right test, and then you get the response, you get the test feedback a lot more quickly, right? So that's the idea. Okay, so now it starts doing things. Let's at least see this to the completion, and then we can switch back to the slides. So, and now it's recording the build, and then it's doing the subsetting, and then now it's downloading Gradle, and then it's going to start building. Okay, all right, there it is. So don't scroll away. I hate this about GitHub Action. So what happened is, sorry for that. Sorry about the jarring screen. So what we wanted to see is, the Launchable, when we asked what Launchable, what subset we want to run, what we should be running, it correctly responded the test case that we modified. So, shouldn't be a real surprise there. And then collectively we find a failure. So that's a kind of flow in which we can use Launchable. Actually, I should mention one more thing. So depending on the project, right? So if the idea of cutting tests feels a little too scary to you, there are a couple of things we can tell you about. So if you this is useful if you have like a large test that's too big to fit into the pull request validation, then you can create a subset to essentially shift some tests left without paying for the whole price. Or you could also do, you could sort of also ask the rest of the test cases and then first run the subset and then the rest of the test, right? So that way, if Launchable does the right thing, then you get the failure immediately because the first set is going to likely catch the problem. And if not, you're still running all the other tests. So, your coverage didn't go down, but on average, the feedback cycle that's go drastically down. All right. So I know, I hope this makes sense, but if not, then again, there's the community is in the communication channel is there to answer any questions. So I looked at in this demo, I just used 25% because I was looking to just select one test, which is the real case. Now, in reality, your test is a lot bigger. So what's the right percentage to choose is a little more complicated question. So, so we help you make that choice by computing what we call this time to first failure. So here's the way you look at this is here's all your test cases. Like if run first test case, like you're running 10% into test cases, that's certainly 100%. And then on this y-axis is how long it takes for us to catch, for you rather, to catch your first regression. So this red is a baseline, which we think is how it's happening if you're if you're running testing random order, which is more or less what happens by default. With Launchable, we are making that ordering more intelligent. So we expect that just by running a little bit of test, let's say 5%, you're getting to, we catch about 80, I don't know, 2% of the regressions here. So you can look at something like this. Okay, so if I'm willing to tolerate, like 80% of the good quick sniff testing, then probably you're looking at, 10%-ish. Maybe your bar is much higher, like, the 95%, then that will be here. And then so time and the effectiveness is a trade-off. So, this kind of like a quantitative approach to how you create essentially a smoke test was never possible. So that's what we're trying to achieve here. And then, again, in the real world, the test is a lot bigger and complicated. So just to kind of translate to help you kind of mentally picture what kind of real world impact this translates to. Now we have a team that we are working with, which takes the whole cycle. This turnaround time for the test takes 2 hours. That's because they have a embedded Linux-based build, which by itself takes 1 hour. And then that gets flashed to the device, and that test takes another 1 hour. This is even after parallelization. So with our technology, they're able to cut that test execution down by 15 minutes. And then, so that combined effectiveness, the turnaround time went down by 40%. And they're running 400 of these test sessions per week. So, you can imagine this adds up to a pretty sizable number, which is kind of this kind of impact. So again, as a developer, I feel like I don't need any convincing. You don't need any convincing that the shorter test feedback time is crucial to your productivity. But what these numbers going to do is it makes it easier for you to make that case to your boss. So we have more materials on our website that talks about this real-world impact, again, to help you convince your bosses. And then I should also point out that the Launchable is free for the smaller teams and also for open source projects, because I love open source projects. And then beyond that, it's $20 a user a month. So let's face it, like if you think about how much we are paid as a developers, I think the $20 a month is very much worth it. So, or I should say, like you deserve it is what I wanted to say. So with that, I guess I kind of ran over the 15 minutes time, but that's the end of the presentations and demos. So I think let's see, let me look at if any questions have come to the chat window or this Discord community. I'm not seeing anything there. So, but here's the opportunity if you wanted to ask. If not, then I guess I think we'll call this a wrap. And thank you very much, and have a wonderful rest of the day wherever you are. All right, bye.
Thanks.